With that, I would like to introduce our first speaker. We have a speech, or we have a talk called Combined Use of Microwave Assisted Extraction and Saponification for Food Quality and Safety. That'll be introduced by Diego Carnaroglio, who will speak to the topic generally, and then Giorgia Purcaro will speak to the topic in detail. So I would like to read a short introduction of our two speakers here. Diego Carnaroglio graduated in chemistry at the University of Turin, Italy in 2011. Following that, Diego joined the Department of Drug Science and Technology and obtained a PhD there in 2014 in the topic of pharmaceutical and biomolecular sciences. His main research interest was the application of microwave and ultrasound energy sources to improve chemical processes. Diego then joined Milestone in 2015 and today is the Application and Business Development Manager. He's heading the application and technical department to develop new innovative solutions to drive the company towards new products to meet customer needs. Giorgia Purcaro has a degree in food science and technology and a PhD in food science from the University of Udine in Italy. She spent her postdoc at the University of Messina working on advanced chromatographic techniques. In 2011, she won an Italian grant for young scientists. She spent that grant as a research assistant at the University of Udine working on food contaminants using advanced chromatographic techniques. In 2015, she was appointed as R&D Director of Chromalient, where she led a team of researchers carrying out projects in tight collaboration with the university and private companies. After 2 years, she was animated by the desire to expand her portfolio of skills, so she moved to Dartmouth College, USA, to study data handling of metabolomics data. Finally, in 2018, she was appointed at the University of Liege as analytical chemistry professor at the Gembloux Agro-Biotech department. Her main research fields include advanced analytical techniques in separation science, with particular emphasis on multidimensional comprehensive gas chromatography, which we know as GC by GC, and liquid gas chromatography, which we know as LC-GC. Moreover, she works towards miniaturization of the sample preparation step to prove the reliability and robustness of advanced analytical separation tools, to apply them in many fields of interest at a routine level. In 2010, she won the Atrea Award for the most outstanding contribution in the field of separation science by a junior scientist. And in 2015, she was awarded the Phillips Award for her outstanding contribution to the field of GC by GC in honor of the inventor of the technique. And in 2015, she was included in the list Top 40 Under 40, published by the Analytical Scientist magazine. So after that introduction, I believe that their talk will be presented as a recorded file.
Thank you for the kind introduction, and thanks to the AOCS to give us the opportunity to present here today. Hello everyone, my name is Diego Carnaroglio from Milestone SRL, and today I'm here with our guest speaker, Professor Giorgia Purcaro, and together we are going to talk about the use of microwave in simultaneous extraction and saponification approach applied in food quality and safety. I will deliver a couple of minutes of presentation of our company and what we do. After that, I will leave the floor to Professor Purcaro. As you know, in analytical lab, we are used to work with modern equipment capable to deliver the final results in just few minutes. But when we look to the sample preparation, very often is the bottleneck of the entire process, because it is composed of several steps with a lot of handling required. So at the end, sample preparation today is still time-consuming and labor-intensive. I try to summarize here just a few of all the steps required in sample prep, starting from sampling, homogenization, weighting, solvent addition, Then for food material, we have hydrolysis when required, or then extraction, filtration, cleanup, and so on. If we look to the possible causes of error in a chemical analysis, we see that sample preparation is on the top, followed by human error. They work together because basically, as I mentioned, several steps are needed in sample preparation where handling is required, and for this reason, human error is the second source of possible error in the chemical analysis. Based on that point, I want to introduce what is the Milestone mission, which is a help chemist and help chemist in the sample preparation procedure. We have over 30 years of experience in the application of microtechnology in sample prep, both in elemental analysis and molecular analysis. And we developed over the year over 50 patents around this technology. And we have today a good worldwide installation of our microwave system. We have a complete portfolio regarding the microreactors, starting from conventional microwave system, then moving to more modern reactors, stainless steel microreactor. But the common point for all this system is the capability to work in pressure, medium pressure or even high pressure. And we are capable to deliver with our solution, we call it rotors, capable to work up to 15, 24 or 44 position in a high pressure in a single run. Generally, an extraction process with microwave require 20, 30 minutes, maximum 1 hour, and it is of extreme value to be capable to process such high number of samples, up to 44 samples in an hour of heating with microwave. So apart the throughput that is really interesting for routine lab, there is the point of the pressure. So the pressure allow the chemist, the analytical chemist, to heat up the solution, the extraction solution above the boiling point of the solvent used during the extraction. And this will speed up a lot the process itself. So at the end, you have a shorter process when you apply a closed microwave reactor, and you are able at the same time to increase the efficiency of your sample preparation protocol. I will conclude here my quick intro about the microwave to give you the opportunity to Professor Purcaro to present and to talk about the research that they do in the laboratory, and in particularly she will go in detail about the application and advantages of the use of microwave in simultaneous extraction and saponification protocol applying on food matrices. Thank you very much for your attention, and Giorgia, you have the floor.
Good morning, good afternoon, wherever you are, and thank you for your introduction. So today I'm gonna present you some example of the use of microwave-assisted extraction that we are performing in our lab, mainly for the analysis of food. In this regard, in our lab, we face different problems related to food. We are working on food safety, so contaminants, food quality, and authenticity from different viewpoints. In this regard, what we are trying to do is to merge the advantages of the routine approach, which we know that needs to be fast, simple, reliable, possible in fingerprinting approach, with the approach using research which tend to maximize the level of the information obtained. But if we can merge and have advanced routine method, highly informative, but at the same time simple, reliable, and fast, we can be on top of the possible frauds, possible new frauds and new contaminants. And in this regard, I will discuss the role of microwave assisted extractors, so the use of the microwave for implementing these advanced routine methods. I will discuss mainly two fields of application: food safety and the quality authenticity of food. Regarding food safety, the topic that we are working on intensively is the contamination from mineral oil, so MOSH and MOA in food. When we refer to mineral oil, we refer to a wide range of products deriving from petroleum distillation fraction, which are mainly divided in MOSH, which is the saturated hydrocarbon fraction, and MOA, which is the mineral oil aromatic hydrocarbon fraction. And both of them are composed by several sub-fractions. What we know is that the MOSH can accumulate on human body, but we still have not enough information to evaluate if they are toxic or not. For the MOA fraction, we have more information on their toxicity, in particular for the structure that is recalling the one of polycyclic aromatic hydrocarbons such as benzoylpyrene, that we know that is a highly toxic carcinogenic contaminants. So this contamination is of concern and is a hot topic in the European Union. Although this contamination is not new because it's known since 1989, the attention of the public opinion arose only in 2009 following a series of scandals that reported the presence of these contaminants in food, ending with the last scandal that appeared in 2019 related to the presence of MOA in infant formula. The contamination of such contaminant of MOSH and MOA in food can occur at different levels of the food chain, starting from the raw material arriving to the final product, and it can due to contamination indeed, but also from migration, due to migration from the food contact material, or the use of some emitted additive and processing aids. In this case, we are referring to food-grade mineral oil, so the aromatic fraction is being removed. This analysis is very challenging because we have only on the data interpretation and data integration a variability of about 20%, which is huge, and that we need to add on top of the variability due to sample preparation, which has to be tuned and optimized according to the specific metrics. This is one of the first perfect topics where advanced techniques, such the one that we use in research, are actually needed at the routine base. In fact, the European Union, both the Joint Research Centre and the EFSA, pinpoint towards the use of GC as a confirmatory method for this analysis. Needs to highlight that already the routine method uses an hyphenated technique, which is the LC combined with the GC, which is not such an easy technique to use. So the JRC guidance reported decision 3 to guide us towards the purification steps that are needed for MOSH and MOA fraction. But nothing is said about the extraction step, which is fundamental, because at the extraction step we can also perform a first purification, and much more importantly, we can perform at the same time extraction and enrichment. And it's very important to avoid a high manipulation to reduce the possible cross-contamination due to the fact that MOSH and MOA are ubiquitous components. In this context, microwave-assisted extraction is very powerful because it can perform enrichment and extraction simultaneously, performing saponification and extraction in the same vessel, thus increasing the sensitivity, the recovery, and at the same time shortening the extraction time and the manipulation needed along with the solvent, so reducing the contribution of blank and possible cross-contamination. Moreover, it has been shown that the use of microwave-assisted saponification and extraction allow to extract not only a higher amount, but clearly a pre-existing contamination due to the contamination of the ingredients used to produce the product, as in this case, for instance, of the baby food, compared to the contamination that occur for a superficial migration from the packaging, so that remains superficial in the food. Here you can see this clearly this difference. This extraction and enrichment method can be used either with the routine method, the LC-GC, which provide a hump for the motion, a hump for a MOA fraction, but also in combination with the confirmatory method, which is the GC-GC, which allow to separate also the subgroup present in MOSH or MOA fraction, allowing a more detailed characterization of the contamination. Our approach is to merge the two approaches, so the routine and the confirmatory method, in a single analysis using an LC-GC FID MS. But I won't go into detail for this application. I invite you to follow my lecture during the main conference. What I can say here is just that we use a simultaneous FID and MS detector, and parallel more than simultaneous FID and MS detector, to take advantage of the quantification of the FID and the additional information on the nature of what we are looking at from the mass spectrometer. We have also developed in collaboration with Liege, in this case with the company, a new algorithm to be able to quantify reliably in the 2D plot in order to really propose this method as a routine method as well. But let me move forward to the other example regarding quality and authenticity. In particular, we work on the lipid fraction and on fatty acid profile and minor components. On the fatty acid profile, let's start with that. We know that fatty acids are important from a nutritional viewpoint. We need to differentiate between saturated and unsaturated, and between the unsaturated, between the cis and the trans fatty acid. And this is required by the regulation, and is used also to identify adulteration. So we also, this is particularly important because of the campaign that has been launched by the World Health Organization to aim towards a trans-free products by 2023. What we are doing now for analyzing the fatty acid profile, we have many reference method also from the AOCS, like for instance the method CA2B that covers sample preparation, and for the gas chromatographic determination we have again a AOCS reference method, also an AOC, which are mainly which have mainly the same principle. Both methods recommended a 100-meter column and has an analysis time of more than an hour, and often two analyses are required because it's very difficult and time-consuming to resolve all the isomers, cis and trans, for instance, which are important because we need to detect the presence of trans. We need to use different column, so most often is a compromise to try to optimize the level of information that we can extract, or we need to perform multiple analyses to have all the information that are needed. What we are proposing in this case is the use of GC-GC with a mid-polar column in the first dimension and an apolar column in the second dimension, using a flow modulator, a reversed field flushed modulator, which is also an economical solution for GC-GC. What we did was to compare the traditional approach using the standard method of the AOCS for the sample preparation with an alternative approach using actually the microwave technology to perform extraction and derivatization at the same time, and then couple with GC-GC for the separation. The advantages of GC-GC, I think, is well known to the many, is that we have a two-dimensional separation which allows us to easily separate partially coeluted compounds, as you can see in this case, and you see you can also take advantage of the structure and having a separation that can support your identification in the 2D plot. We validate the GC-GC separation and analysis, reporting very good intraday and interday repeatability of both retention time and area, and we estimate the limit of detection and quantification based on the signal to noise ratio, and it was very, very good in terms of profile percentage that can be detected. Our step forward was to compare, so the traditional method of FAME extraction and derivatization. We compare both the method reported by the AOCS and another one for milk, specific for milk, with a extraction and derivatization step performed in a single step in the microwave extractor. Here you have an example of the comparison for a milk sample with two different time applied to the microwave assisted extraction and derivatization, and as you can see they are very much comparable. We then choose to carry on the analysis with 5 minutes to shorten and increase the throughput, and we compare with the reference AOC official method for many kind of foods, and here I'll show you some examples, like the case of fish oil. Here you can see that the comparison is very good. Other ready-to-eat meal like madeleine, cuisine, lasagne, spread cheese, and again the results were very comparable between the two methods, so the official one and the microwave one. We also consider the nutritional label on the saturated percentage, and we compare it with what we obtain in the GC-GC chromatogram, just considering the saturated fatty acid. Here at a glance is easier to see the comparison, also on comparing the results obtained with the reference method. On the other side, we also use microwave for the analysis of the alkyl ketones and sterols in fats. So sterols are important marker of authenticity, and they are regulated for many kind of oils. On the other side, DAC, so the alkyl ketones, are a byproduct of chemical interesterification, and there are some concern on their possible toxicity in the product, but anyway they can be used, and they can also be used to detect the fraudulent use of chemical interesterification when is declared enzymatic interesterification. On this regard, we perform the saponification on the microwave. Then we did an extraction with hexane, unsaponifiable extraction, and then we perform an SPE purification, from where we extract, we elute the DAC as the first fraction, and here you have an example of a GCFID that then was run also in GCMS to have the confirmation of the identity of all the alkene ketones present in the sample. And here you have some example of chemically interesterified oil or non-chemical interesterified oil where the DAC were not detected. The same method of SPE, so from the same cartridge we can also elute the sterols, and we are doing this. Indeed, we see that the comparison is rather good, but This is still a work in progress to try to have a better accuracy of the sterol results, because we had the coelution of some desmethyl sterols that we want to remove to avoid that can alter our quantification. So with this, I hope that I gave you an overview of the flexibility of the microwave-assisted extraction and the possible use that you can have in a lab of this technique. Finally, I wish to thank my research group for the daily work, all the sponsors that support us daily, in particular Milestone, to invite me to present to this seminar today, and last but not least, you for your kind attention.
Thank you very much for that presentation. It's quite an ambitious field, because you can't take anything for granted. You can't take for granted that the materials that you're buying to do the preparation and extraction are pure enough. So would you mind addressing, what do you think are some of the biggest challenges, the things that make this kind of work go the slowest? Is there significant challenges you've had to overcome in the process of developing this work?
So it mainly depends from the application that you're referring to, because I've shown very different applications. So for mineral oil, the complexity is high, because after extraction we have the purification step, which is not trivial at all. And as I mentioned during the presentation, it has to be tuned for every single matrix. So at the moment, we are far to think to have a single universal method, whatever is the matrix in that field. While when we deal with the other part of the application that I show, so for instance, the dark and the sterols, we are working on developing a protocol that can work for every kind of oil, and is not particularly challenging. At least we hope that it won't be. We haven't found any particular concern at the moment.
Well, thank you very much. I'm looking forward to your presentation at the annual meeting, and wish you all the best in that. That's the last of our questions. So thank you very much, and very informative talk and very impressive work. So thank you very much.
Thank you. Have a good day.
Thank you.
Thank you.